Okay. So sorry, just have a short dry run. Yeah, seems to work, Tom. Thanks. Next slide, Tom. Yeah, excellent. Okay. So, welcome. Do we give another minute, co-chairs? People are still joining.
Setting up all my windows, so yeah, another minute is a good thing.
Okay. Is for everyone this slide chopped? A quarter, something like that, because
IETF 11.
Yeah, indeed. Okay.
11 November 202.
Yeah,
that was yesterday, but it's the same slide deck. Sorry, Peter.
it's the same slide deck. Yeah,
Same
in my
thing.
own in my own view, the slide deck is it was shown. Then I
I made
switched
my
on.
window bigger, now it is better, but it should
Okay,
itself on it.
resize probably. It's a resize thing. Yeah, it's a slide of yesterday, but I will jump to slide 16 in a moment for session 2. Yeah.
The same as yesterday, only less.
Yeah, exactly. I think we can start with a good crowd. Welcome for the second session of the Nsop for today, 12th November. Okay. These are the Nsop chairs. Myself, Tim Wyszynski, Suzanne Woof, Warren Kurami is the area director, Jebaroom the same. The minutes will be taken by Paul. Paul will use his own, will take minutes on his own laptop, not using Codim, or it's now Hedgedoc, I think called. But please, if you want to drop text, use the URL here shown, Codim MD or Hedgehog of Notes. It's today, it's notes.ietf.org. And we will integrate the notes, the minutes. Okido, we assume that you are familiar with the note well, and also with the IETF code of conduct. The short version is be a nice person. Good. Any other things? Well, yes. Agenda for, sorry, the agenda for today. We made a small change. We added Wes Hardaker to the agenda for today. After the discussions, after the presentation, there was quite some discussion in the Java room on NSEC 3 parameter guidance. And the chairs and Wes, luckily, thought it was a good idea to continue this discussion also in this session. So this is the agenda for today. There's the, oh, sorry, I mess up a bit. Sorry, excuses. IETF hackathon results will be presented first by Tom, then DNS catalog zones by Willem, and then the guidance for NSEC 3 parameters by Wes. And then there's the new draft by Peter Thomason, automatic DNSSEC bootstrapping. Yeah, let's go. Let's get started. Tom, you can ask permission. Yeah, I will give screen to you.
All right, thank you. Can you hear me okay?
Yes, excellent.
Perfect. All right. Can everyone see the slides?
Yes, thank you.
Even better. Thanks. All right, thanks. I will be presenting the hackathon results of the extended DNS error response test that we did. It's based on the draft by Roy, as far as I know, Roy Arends, and it builds on extended DNS errors. Hence, either that's how I will be calling it. I'm told Roy, the writer of the draft, doesn't enjoy the abbreviation, but for now it works. This was the main topic of discussion even during the DNS op interim meeting on the 26th of October. And there it was discussed that it would be nice to have a measurement that what would happen if a authoritative would send a unsolicited EDNS option to in a response to a resolver. So there was also an email about this on the mailing list. So that's what we tried to do. For this, we used eBPF, the extended Berkeley packet filter. This is way beyond what maybe some of you know as what was used for TCP dump. It now runs in the inside of the Linux kernel, so it's a restricted subset of C is what was used. And with this, you can create nice name server agnostic or even resolver agnostic programs, which you don't have to anticipate beforehand. So it's just a drop in, if you will. And here linked, you see the place where we have a repository for the code. So you can, if you want to, try it yourself. Trying it yourself is actually really easy. So you clone it, initiate the submodule, then load the program into the kernel. What is omitted here is that you will need to have some dependencies, but that's fine. And then here we show that it actually works. So the URL we used here is report.nlnetlabs.nl. As you can see here, because this is, for those of you who like to look at code, is how we can configure this program. That's the word I was looking for. So we have a report domain, which, as I said, is a report.nlnetlabs.nl. Then we chose the EDER code. As you see there, it's the first one for the experimental ones. And then we have a sampling rate. This was also discussed during the interim meeting that it would maybe be nice. Currently, we tested with 100%. But maybe other tests could be done without. So for the measurements, we used a RIPE Atlas. For those of you who don't know it, it's a RIPE NCC measurement platforms. It has about 12,000 probes, and these probes you can ask them to do a lot of things. For here, we used them to DNS queries. We asked them to do two. Either to our baseline measurements, which was to neither.nlnetlabs.nl, which just got a response back. And we also did a measurement to either.nlnetlabs.nl, which got back a unsolicited option. As you can see, most probes participated, and we used Python program to, as you can see that we linked there, to process the results. Let me check. Yes, I think I have everything. All right. So what we learned, well, about 0.5%, so 95 resolvers get a baseline but don't accept the unsolicited message. Then you can see a lot of resolvers there. This is mostly due to that the RIPE measurement probes have more than one resolver in their respective networks. So roughly two, less than two usually. And then the funny part is on the right here, you see 73 do respond well to an unsolicited EDNS option, but don't respond to our baseline, which we think may be due to just margin of error of the internet. But as we conclude here, oh, sorry, I see Peter. So Peter, the left circle means the baseline, which most of the, yeah, I say most of the resolvers got back. So that's fine. So that's the baseline is good. But then on the right, you see the part that doesn't overlap. That's responses that are only from the either and not from both. So in the middle, there's positives to both, and on the right, there's just a positive response to just our test, not the baseline, which makes it weird. Okay, if that's fine, I'll continue. I see Ben Schwartz asked the question. We'll get to those at the end, I think. All right. So we'd like to answer the question: would either the adoption of either give operators more confidence to DNSSEC deployment? We don't know for sure. Maybe not, but we think there could be a missing piece. And the missing piece could be something like a driver in DNSSEC. So that would mean it would be something like DMARC maybe. So you get the reporting without the failures, and you could place a bit in a DNS hash algorithm field, or maybe somewhere else if other people have other ideas about this, so that you, as I say, get the failures without. Get the reporting without getting the failures, which would be maybe give operators more confidence to deploy DNSSEC. This would also allow for a quick rollback in case of any other failures, really, for example, packets that are too large. So that has been what we did. We link again to the implementation, and there could be an idea for a new document driver in DNSSEC, and we would very much like your opinion.
Thank you, Tom. Thank you very much. I do see Peter and Ben on the queue. Peter, please.
Hello, can you go to slide 5, please?
Of course.
Next slide.
All right, sorry.
One more.
One more.
Sorry, I counted actual slides, not your numbering.
Yeah, fair enough.
In the EDNS response, just above the questions section, there are 2 trailing zeros. Is it
Yes.
a bug, or is the spec unclear about something?
No, that's a bug. So if we go one further, you see a trailing 0 in our reporting domain. We suspect it's that.
Sorry,
We suspect that's a trailing error from us. So
right. Okay. So the spec is clear on this.
It's a bug.
Okay. Thank you. Thank you.
Okay, Ben, please go ahead.
Hi. So I'm just a little confused. You're sending an unsolicited extension in the response.
Correct.
Why? Why?
Because
are
this
you
was
proposing
discussed during
we
the
should do this
interim
as
meeting,
okay.
that this would be better than the resolver asking for the reporting agent with the EDNS option, because this is also sent to the DNSOP mailing list by Roy Arends. He said that authoritative are more likely to not respond well to an EDNS option that they do not know about than that resolvers are to getting a unsolicited EDNS option.
Okay, so it seems
So
like
the
this test,
intention of
half of
the,
that. It seems like this data provides half of the test we need for that, right? Because the other half is to run the opposite test and send a nonsense
No,
option.
so we have the baseline measurement, neither that does not provide the unsolicited option, and either does provide the unsolicited option.
Right.
So strangely enough, there are also responses which are received from resolvers that only send the unsolicited option. But you know, I think that's just the error rate that you would normally get from any measurement. So I would
okay, I guess
estimate
I'm confused there too. It seems like there are more clients that are unable to reach the EATR endpoint than there are clients that are unable to reach the
That's right.
non-EATR endpoint. So
That's
that's
correct.
just a positive error rate, right? A positive impairment of accessibility.
Yeah.
So we can't say that it's safe to do this, you know, in some absolute sense.
No,
Right.
that's true, but it's only like 0.1% or something.
Okay.
If you calculate the error rate, which is already there, but also
0.1% sounds pretty high to me.
yes, but therefore there's also the sampling rate, right? So you don't have to send the unsolicited option with every response. It could also be like on 5% of the responses or something.
Okay.
Anyway, we just did
That's
this.
also true in the reverse direction. That's also
sorry?
true in the client to authority, in the resolver to authority direction. The resolver could tag only a small percent of queries.
Yes, that's also indeed that would also address the case that not all authoritative would respond well to unsolicited or unknown EDNS options. Yes.
Okay, yeah. So I would like to see that tested too, especially since it's as Ray points out, that behavior would be clearly out of spec.
Noted.
Thanks, Ben.
Okay, thank you. Thank you for your feedback. Yeah, I closed the queue. I saw Victor and Peter also want to join the queue, but given time, we have to continue with the next presentation. Please continue the discussion on the mailing list and yeah, any other means. Willem, please. So the next presentation is on catalog zones. Willem, I'll give you permission.
Okay. Okay. Yes. So DNS catalog zones is a method for automatic DNS zone provisioning among DNS primary and secondary name servers by storing and transferring the catalog of zones to be provisioned as one or more regular DNS zones. So what does that look like? On this slide, there's an example catalog zone. So it's simply a list of zones listed in the catalog zone called member zones. On the slide is an example showing what it looks like. They are enumerated with uniquely valued labels in a zones section in the catalog zone as pointer records. The example on the slide uses the domain name catzone, but that name is actually free to be chosen. One could consider something below a reserved TLD, for example, such as invalid. The picture shows a primary and its relationships with secondaries. So the catalog zone, catzone, is distributed along these relationships. And from the catalog zone, the secondaries learn that they should serve example.com, example.net, and example.org. So what's new since version 2? We introduced the terms catalog producer and catalog consumer to describe everything more clearly in the draft. Producer generates the catalog zone and a consumer processes it. Producers and consumers do not necessarily align with the primary and secondary relationships. For example, in this slide, you see that there's one machine producing two catalog zones. For one, the blue one, the producer is also the primary, and the consumers are the secondaries, and the other catalog, the green one, is generated by the same producer, but the primary is not a producer. So other sets of configurations are possible. It's nice that we have 4 authors of open source name server implementations working on this draft and discussing the draft, because the resulted this resulted, I think, in the most permissive and generic way to handle and implement catalog zones. For example, we no longer have text on optimizations that are a consequence of predictable owner names. The organization of the current draft has been geared towards describing what the catalog zones looks like, what the basic operations are and how they work, adding a zone, removing a zone, migrating a zone, zone state reset, and how catalog consumers should deal with occurrences such as member name clashes and member node name changes. Member zones can have properties. Version 4 of the draft has more uniform and consistent description of how properties may be defined. Properties from standard documents are always one label below the zone member. We described 3 such properties in the draft, which are all optional, and I will go over them quickly in the coming slides. Implementations or operators of catalog zones may also define their own properties below the label Ext, which is itself one label below the zone member name. A property described in the draft is the COO property, COO, from the change of ownership, and it allows for controlled migration of a member zone from one catalog to another. In the example, you see that the COO property of the catalog zone, cat zone, signals that it's will be migrated. Its member, example.com, will be migrated to the catalog other cat zone. So the consumer has the member name cat zone in cat zone, that's the unique ID A, so to say, associated with example.com. The zone is then not migrated yet, but after the consumer receives an update that adds example.com as a new member of other cat zone, it knows that example.com came from catalog cat zone. It knows the associated member name, unique ID A, so it can look up the COO property and see that the migration has the catalog cat zone's consent. So the whole operation can be performed rather stateless, which is nice. This is actually how the Power DNS implementation handles catalog zone migration. So if the member zone name in the new catalog is different from the old catalog, then the zone associated states, such as zone data and DNS keys and whatnot, is reset. If it remains the same, then it's migrated to the new owner as well. So note that the old owner has control whether or not the new owner will receive this state, because it can add the COO property and change the member name at the same time. Instead of having one set of configuration per catalog zone, the group property, which is also defined in the draft, allows to have more different sets of configuration in a single catalog. In the example on the slide, example.com is configured to be signed with NSEC3, and example.net is configured to not be provisioned with DNSSEC. This allows for atomic change of configuration of member zones, and it fits well with NOT's concept or NOT's DNS concept of templates and also NSD's patterns. Then we have another property, the serial property.
Sorry, Willem, something is not. The slides are not synced in.
Oh, with me talking. No, yeah, that's true. Sorry about that. So I have notes as well.
Okay.
And that's,
excellent.
yeah, so this was the group property, by the way. So it's, the atomic config. Well, what I just said. The serial property is another property defined in the draft. Its intention is to increase reliability of zone updates because, if you have a large number of secondaries and a large number of zones, notifiers might get lost on the internet, or secondaries might be down and not receiving the notifiers. And it's also, the intention is also to reduce the notify and SOA query traffic if you have lots of secondaries and lots of zones. So how does that work? So the serial number of the member zone SOA record is in the serial property of that zone. Then if there is an update of the catalog zone with a new serial number, the consumer, which might be a secondary, can then fetch the zone because it knows that it has a different SOA number than what it's already serving. No notify is then needed. Also, if the catalog zone is fresh, then it may clear the refresh timers for the member zones. So this property is an optimization built upon catalog zones, and it's not dealing with the catalog itself. So that might be a reason to not have it in this document and to split it off to a draft building upon catalog zones. I don't know. I leave that up to the work group. We also updated the security section. It now makes very clear that the administrative control over what zones are served from the configured name service shifts from the server operator or the consumer of the catalog to the owner, the producer of the catalog zone content. And we have a author edit, Peter Thomason. He contributed text and IDs and did a lot of work on discussions, so he's an author now too. So this version of the draft is the result of thorough review and discussion with the goal of getting it in shape for publication as RFC. It has catalog zones specified to the best of our ability, and we request you to review it thoroughly with the documents readiness for working group last call in mind. And that's it. We can now answer questions.
Thank you, Willem. I see Peter van Dijk in the queue.
Well, not actually a question, more of a comment. Wes, do you want to go first? Go ahead.
I actually said, no, you should go ahead. Well, so actually, I do have a clarifying question. So in your example slides, you used real looking TLDs at the end of your zone, and in the document you use $CAT-Z. One of the things I worry about is these will leak because it's the DNS and everything leaks. And so what are you actually thinking for naming records on the left-hand side of your records with respect to that?
So you're worried about the cat zone TLD that we used in the examples on the slides.
Right. So in your slide examples, you didn't have $CatZ as
No,
as
that's right.
the special
That's,
token.
I wanted to use actual real-looking examples that it's actually
Right.
you
Well,
can
so
yeah.
right, with real-looking examples, I'd be very tempted to require something under like .arpa or something like that that we can, black hole or something, because you will end up leaking a new TLD, and that would be
Yeah, I agree. Or .invalid or something. Yeah. I'll update the slides.
How about recommending that people use names they own for their catalog zones?
Yeah, or maybe both. We could have a recommendation saying you either have to own the name of your catalog or use a reserved top-level domain.
Yeah, something like that.
Sounds good.
Hi, Paul speaking. I just wanted to say that initially I was really skeptical about catalog zones and being too much of a put configurations into the DNS thing because we're DNS people view. But since then I have started deploying this and I'm really super happy with it. I can run different vendor DNS software without having to muck with configuration files and different syntaxes. And I think this will really help diversify name server space where people can easily run multiple name servers. So I just want to say kudos, go on, make it better.
Thanks.
Victor, please go ahead.
I didn't see a discussion of the sort of security of the transport of this stuff. How do we know that the catalog zone is good stuff?
That is in the draft. I didn't put it on a slide, but it is in the draft. It was already in the draft for a long time. So we recommend to use private transport, like transfer over TLS.
Mm-hmm.
And also use authenticated channel with TSIG or otherwise.
All right. Have you considered signing these zones? Because one could imagine putting a trust anchor right on the receiving side for these zones and then validating content signatures and all kinds of stuff. Is that reasonable or is that crazy?
I don't know. Yeah. Or maybe
I mean, if you want
MD or something, yeah.
Then you can have hierarchical distribution because you can trust it from the origin. I don't know if that's a useful idea or not, but anyway, something.
I don't know either, but it's interesting to consider. Yes.
Thank you, Willem. Thank you, authors of catalog zones. So it's close to working group last call. I hear there's some work to do for you, for the working group. Please review this document, this version, and certainly when working group last call, you're kind of obliged to have a review the document. I think you also, because it's already in use by some of the vendors already put this to use, and I think there's also feedback from users. We just heard from Paul Wouter, so please, that's good. And what else? Is there still interop testing going on?
Yes.
Yeah. Okay.
Yeah, that's still going on, but it would be so. So we have I think this document is ready.
Yeah.
So it would be nice to have a review while we are doing interop testing.
Excellent. Okay. We'll ask the working group to do a review, interop testing, and then we can go for working group last call and have again a review by the working group and move forwards. Thank you very much. Yeah. Next is Wes. I know you want to run your slides your own, but you can also use the shared slides from Meet Echo.
I
what you prefer.
did a request to share.
Oh,
slides.
sorry. Yeah, I do see it. Yeah.
All right. All right. Here we go. So yesterday, was that just yesterday? I've lost track. Was actually a very fruitful conversation. I'm notorious for deliberately putting up things that I expect people to be against. So yesterday was no small. Was definitely in that case. So I want to try this again. Today is a little bit different. Today, I actually think, based on conversations on the mailing list and on the discussion yesterday, that we may be at a good point for really wrapping this up with some text that I will propose at the end. So based on discussions yesterday and based on the list, we know that we want zone publishers to move to iterations equals 0. I think there's a lot of consensus around that. Not today. We know that we want validators to start enforcing lower counts, and that serve fail is better than insecure because insecure allows takeovers and serve fail is at least denial. But we want to do all of these at a reasonable deployment rate. It's not an instantaneous move, though we've made a lot of progress in part thanks to Victor's reaching out to a lot of people. But this reasonable deployment rate is not going to be immediate, right? It's going to be large. So how do we get from where we are today to accomplishing these goals? So we want zone publishers to move to iterations equals 0. So this is my recommendation for how to modify the draft. So this proposed text. This is actually a suggestion by Paul Hoffman that I made a little bit stronger, and it's in section 2.3, and it's in the middle of a paragraph. So some of these are a little bit hard to read out of context, but I'm really trying to propose essentially text that will go in. We won't do wordsmithing live, but NSEC mitigates this concern, and if NSEC 3 must be used, then it should have an iterations count of 0, basically. And so what I want to hear today is there anybody that can't live with this text? We'll discuss in a second, timelines, but this is zone publishers really should do 0. I see nobody in the queue, so that's a win. All right, so how do we get to B and D? So B is we want validators to start enforcing these lower counts, and how do we do this at a reasonable deployment rate? So for this, we're going to steal text from Petter. Thank you. And it will go in section 4 that says, really talks about timelines, right? So as of November 2021, setting an upper limit of 100 iterations for treating a zone as insecure is interoperable without significant problems, but at the same time still enables CPU exhaustion attacks. And for this reason, validating software vendors are encouraged to continue evaluating NSEC 3 iteration count deployments and lowering their default and acceptable limits over time. So it puts it on the shoulders of both software vendors releasing validating resolvers, as well as operational staff, although I don't really put that in there. I should probably add operational staff. Paul 1.
On my screen, I'm 1, so I'll pretend to be Paul 1.
Yep.
So normally at the IETF in RFCs, we don't actually put things like expiry dates in there. So and that's a good reason for that, because we don't really know or can predict what the future deployments will be like. So that we internally have something where we say we'll get back in November 2021 and we'll reevaluate based on measurements done by people like Victor is great. But I don't think there should be anything in the document. We have a DNSSEC guidelines document that tells you what to do or what not to do. That one should be regularly updated via BIS versions, and that's where this text should appear, but not with dates.
So this isn't a deadline, right? This is where we are today, and it's the starting point for what people might want to consider. I recognize I actually was hesitant to put this in the document too, for exactly that reason, that RFCs don't typically have history in them. So I will take that as a complaint from Paul that he would prefer not to have it. I guess, Paul, you're still there. Any follow on?
Oh, sorry. Yeah, I'm still there. Sorry. Yeah, I still think we should not put dates in there. The only dates on RFC documents are the ones from the publication date.
Well, okay. So how about as of this publication, right? We actually have done that in a number of places. You're right that the hard date's probably.
But that's already implied. If you put in a should or a must and the document gets published, then that's the date you have. Like, I don't think we need to put date wordsmithing inside the documents.
Okay. Paul 2.
Just a quick question, and I'm not sure I've been following because I'm busily taking minutes. I thought you said earlier that the suggestion was going to be to go to NX domain, but in the second line here, you say for treating a zone as insecure.
Right. So right now, the NSEC 3.
I just wanted to make sure that that was intentional. If that's intentional, that's cool. Okay, great. Thanks.
The next slide, we'll talk about that. Peter?
Can you hear me?
Yes.
Okay, good. Well, one option would be to take the first paragraph and either move it to appendix and say, well, this is the history appendix, blah, 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 or just delete it because, you know, the second paragraph stands on its own. You know, the vendors have to evaluate what's actually feasible to enforce at any given point in time and, you know, adapt the defaults they ship to current situation, because that's what vendors do anyway. So, I mean, but I really think this is bike shedding because it's not setting any expiry date. It's saying at this specific point in time, the situation was this and this. I don't see any future prediction in this two paragraphs, so I don't really see the objection.
Okay, so I will note before you leave that if we delete that first paragraph, we're deleting suggesting the upper limit of 100, right? So, which may be okay, right? It still leaves it up to vendors as to what to do. Victor?
One possible solution is to just remove the date and say that validators should use a limit of 100 or less. And then, you know, with the less being based on paragraph 2, and just immediately recommend 100 as an upper bound for the upper bound, if you like.
Yeah, but if you do a should, then that limit ends up kind of looking like it's hard coded forever, and that's not what you're trying to say. So we might be able to do that, but word it carefully.
I should say it should use a limit of, you know, no more than. You know, yeah, I see a point. I don't know, but that's an option, is to recommend it as and then say lower if possible.
Okay. No, sorry, a little bit timekeeping, so not contributing to the discussion. I think we all agree, only this is a little bit wordsmithing, so maybe we can take that to the mailing list. Because, sorry.
Yeah, the traditional answer at this point is please send text.
Yeah, but the main thing, everybody agrees, kind of the approach, but indeed we have to be,
All right, thank you.
Sorry.
So the last one is serve fail is better than insecure. And so we talked about this yesterday. So the text I'm proposing, this totally needs wordsmithing. So let's not wordsmith this at all. I sort of put together late last night after not enough coffee again. But similarly, because treating NSEC 3 with a high iterations count is as insecure leaves zones subject to attack, validating software vendors are further encouraged to lower their default and acceptable limits for returning serve fail for large iteration count values. And again, we have text about dates, and maybe 500 is a reasonable starting point. Based on the discussion on the last slide, I would argue that last sentence we should just drop entirely. Anybody have objections to that first sentence, especially being put into the document as our path forward? Yeah, so Peter Koch did want to point out in chat that are we talking about operators or vendors? And it's this tandem thing where that's always a problem. I think I will try and put in wording to talk to both operators and to vendors. That's a good point. Petter, and then I think we'll quit.
Just a quick note from a vendor, because vendors have to do some defaults, and when it breaks by default, users go to vendors and cry. And that's the reason why we try to establish reasonable values. That's it. I mean, of course, operators are free to patch the software or pay vendors to do something else, but this is about defaults, right? Everyone can change the software any way they want.
Yeah, and in some documents in the past, we've also put things like, this must be configurable. You must provide a configuration hub. And we haven't done that in this document. So, all right. I believe, I don't even know. Oh, and then I haven't proposed an appendix, but I think we can do that on the list. And again, that's from Peter. So, all right. I think we're done.
Thank you very much. We do have.
Yeah.
Oh, sorry,
Go ahead.
Suzanne, please go ahead.
No, just that I think we've done all we can here, but please take it to the mailing list and send text because we want this to be right.
Yeah. Victor, you want to add something?
If since Peter Koch is in the audience, I'm curious whether he has any issues with reducing the ccTLD iterations to 0. I notice that .de is currently one of the ones that's sort of slightly on the high side.
Okay. Please go ahead, Peter.
Sorry, that didn't work.
Yeah, we do hear you now.
Oh,
Yeah.
thank you. Apologies for the delay.
Yeah.
Yeah, while I cannot comment on Victor's question to probably to the extent that would please him, my or be sufficient. My concern is this approach of driving this through by way of standard. So that's what makes me speak up here. I think I understand at least part of the goal, but there's a slippery slope in sliding into a compliance game that the IETF usually doesn't engage into. As in, which is why I made that remark. Enforcement is a bit of a strange concept when actually the mantra is that there's voluntary adoption of standards. If you're seriously mitigating a security risk, then that's a different issue. But then that is probably something that ought not to go into a protocol standard, but rather be dealt with in a different way. And I'm missing those signals. And again, apologies for not straightly responding to Victor.
So this is a security standpoint, and we need to document it as don't do this in implementations anymore, right? We're functionally modifying how you should implement NSEC 3. But we'll let the chairs go on. We can take everything else to the list.
Thank you. Thank you, Wes. Thank you, Peter, Victor. Peter, do you have a short remark? I saw you in the queue, but you disappeared. No.
Oh, yeah, I just wanted to say that, yes, it is a security issue, but Wes was faster, so I disappeared from the queue.
Okay, thanks. Thank you. Then we come to the last presentation, automatic bootstrapping by Peter Thomason. Peter, please go ahead. Hi.
Yes, I just requested sharing the screen. Do you really want to share a screen? Yes.
Yeah.
Entire screen, share. All right. Hope you can see my screen. Do we have a hard cutoff at the half hour?
Not exactly, but I think after 5 minutes the room will be closed by
okay,
automatically.
so I will just speed up a bit, and that's fine.
Yeah.
So I'll be talking. There's no problem. I'll be talking about automatic DNSSEC bootstrapping. So putting in DNS records into the parent by means of authenticated signals from the zones operator. I'll explain what that means. So today, when you bootstrap your DNSSEC delegation, you have to somehow get the DNS records to the parent. There's various ways for this, often involving the registrant, which is complicated, doesn't even know DNSSEC exists and all this. And all of the different methods have some downside, at least one, of being unauthenticated, like CDS from Insecure, or out of band, or being slow, things involving multiple steps, for example, the registrant, and error prone, too many parties, no automation, and so on. Especially the authenticator workflow involves too many steps. So you start at the DNS provider, which has the key material. Usually the registrant fetches it through some web interface, then goes onto the registrar, then there's EPP, too many steps, and it takes forever. And the more direct steps are currently unauthenticated, which are the dashed lines. It's promising to consider the pull from the DNS operator directly, but as I said, it's not secure for bootstrapping, although it's in-band, which is nice. And the goal of our proposal is to add authentication here so that you get something that's automatable, immediate, and doesn't require state at the parent. The solution we propose is to transfer trust from the DNS operator. I'll explain what that means. So first thing, you need a signaling mechanism from the DNS operator. What is that? So the goal is to allow DNS operators to publish arbitrary information about the zones they host and do that in a way that is authenticated and per zone. And then obviously the question is how it can be done. The proposal is to use the namespace under each nameserver's hostname, for example, _boot.ns1.dsec.io in our case of our nameservers, and then require DNSSEC on those names so that records are validatable. That requires the nameservers to be in secure zones. And then under this namespace, announcement can be made under some owner names, which are zone specific. Once you have this mechanism, you can use it to publish an authentication signal. You start out with the CDS and CDNSQ records at the apex of the target domain, of the customer's domain, and you just co-publish them under that signaling namespace. And under the signaling namespace, it will be signed with the NS zones keys. So that's from the operator. You can validate that. So you can, as a parent, you can fetch the CDS records as usual from the customer's target zone, from your child, then validate it against this using DNSSEC, and if that's successful, you can provision the DS records in the parent. That's what we call transferring trust from the to the target domain. And you should clean up records when you're done to make sure there's no clutter hanging around. There's a visual representation of this, which is, I guess, nice to have. Let's start out with .NET and .com. .com is where the example.com customer will reside, and .NET is where the provider has a host name for its name server, which is securely delegated. Now, when the customer books example.com, it's usually not secure. And at that time, the DNS provider will add CDS and CDNSQ records at the example.com zone. Our proposal is to co-publish them identically under the name server's domain, under subdomains of that, and sign it there. And then the parent can come, query the child domain, validate against the signal from the operator, and put things in the parent zone. So we use an established chain of trust on the left to take a detour, and as a result, you get bootstrapping for DNSSEC delegations, which is authenticated, immediate, and resilient against active on-wire attackers. There are a few technical considerations I would like to point out. So first of all, there is no collision with a conventional use of CDS and CDNSQ records, because those live at the apex only, while we propose to put them on subdomains of something. So there is no collision. The draft currently also proposes to hash the ancestor labels, for example, example.hashoff.com, ns1.provider.net. This avoids hitting length constraints and has other implications too. But it's a point of contention, and I think it would be great to get the working group's input on that, so we can either do that after this presentation or maybe on the list. I also have a slide on that separately, so hang on. And there should also be an extra label before the name server host name. Here it's called _boot, so that you can delegate the signaling data to a separate zone. The precise name is to be determined. This naming scheme allows putting things in the separate zone so you don't accidentally touch your name server's IP records. You reduce the chain on the name server zone, which you don't have to touch all the time. You can delegate bootstrapping stuff by parent if you want. For example, you could delegate the .hashoff.com thing. You could also provide a discovery mechanism. For example, if the zone uses NSEC, then .com parent, for example, could start an NSEC walk at hashoff.com, .ns1.provider.net and then start bootstrapping all the children which are configured on the name server. It may be interesting to know how realistic this is in terms of practical outlook. There are two deployment requirements. One is that the name server targets are not part of the same zone, because then you can't establish this this chain of trust, because you get a catch-22. So in bailiwick doesn't work for this, but John looked up a few numbers for us and found that in bailiwick only has less than 1% prevalence in .com and .net. So that should be fine, probably also for other TLDs. And the name server targets need to be in securely delegated zones. So the question is how frequent that is. And we did an analysis from the Trencode top 1 million data set, and we looked for all insecure domains, which don't have currently a validation path, what the name server targets are, and if those are in secure zones. When you have that, you can compute the number of bootstrappable zones, which is where all the name server targets are secure, but the domain itself doesn't have DNSSEC yet. So by looking at that, we probably could have done better. We had a bit of a failure rate. We should have retried more maybe, but we got almost 1 million domains, 5% of which are currently secure, which is just a cross-check, seems in the right ballpark. And interestingly, about 25% of those delegations have all name server targets in secure zones. So that's a good sign. And if you consider how many domains have this property of all name servers in secure zones, and at the same time, the domain isn't secure yet itself, then you get that around 22 or 23% are bootstrappable, which is a very, I think, inspiring finding. We also broke this down by top-level domain and by provider. So you can see, for example, that of the .com domains, 23% are bootstrappable, which is 120,000. And the numbers are not as large, obviously, but still, I would say, significant for other TLDs. And then by provider, we looked at the name server zones SOA RNAME field. And if there's if this was non-ambiguous, then we put it here. And you can see that Cloudflare, for example, has 250,000 domains amongst the top million, 76% of which are bootstrappable. So that's around 190,000, which is also a number with high potential impact. Here's the slide on whether we want the hash label or not. I'll first talk about what are the pro arguments, because it's currently in the draft, and I want to explain why it's in the draft. I have personally no stakes at all, and it would be inappropriate, obviously. So I will also say the against arguments, but only afterwards. So yes, please, hash please are the arguments for hashing. So it helps staying within the limits, especially length limits and number of labels limits. So you get a more predictable number of octets you expend on the ancestor. That may help reduce number of edge cases. There's also an ambiguity if you have a domain for delegation with multiple layers, like multiple labels, like foo.bar.net. And if you have a delegation here at bar, then there are CDS records which show up for that delegation itself of the bar.net_boot zone. And that could be ambiguous because it could also signify the bootstrapping records for bar.net, which is different. And there are some other implications of that, and I would like to probably take this particular point to the mailing list. Then it also improves privacy during discovery because to do an NSEC walk, you need to know the hash of the parent. So if you have some private enterprise domain, for example, nobody would reasonably be able to do an NSEC walk if they don't know where to start. And it gives you a flat structure, which may simplify the scanning logic. If you, for example, know ahead of time that you only have 2 labels here in all cases. And in case, so that's an idea I just had. I don't know if that's reasonable at all, but one could say that one should have a more general signaling mechanism. So it's called _signal, not _boot. And then the specific signal would be specified as a prefix, just like the properties for the catalog zones be _CDS, for example. And yeah, so in case you would have multiple prefixes, like in the case of SRV records or something, it would be better if the number of labels here is predictable. But it's just a thought. I'm not saying this is a very strong argument. Counter arguments are to smash the hash. And so obviously hashes complicate implementation. All tooling needs to be able to hash. Makes debugging more difficult. You can't just use dig. You need to get the hash somewhere. And also, I think most notably, it was pointed out that Synthesis is more difficult if you have a hash, because imagine a request comes in for example.somehash, and you would like to dynamically serve CDS records for that. You somehow need to look up what the corresponding target domain is from which to take those records. So you need a mapping, but you need that for the ancestors only. So probably the number of mapping entries you need is few. So you wouldn't need it for example.co.uk, you would only need it for co.uk in this case. Also, for those who like, let's say, a special fetish for weird implementations, you could probably do this with a DNAME record. I know there's implementation problems, so it's a half serious idea. It's cacheable per parent, so it wouldn't be much of an extra performance penalty. Yeah, so the question is whether the benefits justify the added complexity. So what now? We have a signaling mechanism of zone-specific information from the NS operator to the public. It's authenticated, in-band, immediate, and requires no third parties. We propose to use it for authenticating CDS and CDNS key records. Some people have expressed interest, and I think the potential is quite high given the numbers I showed earlier. And perhaps there will be other uses in the future. For multi-signer key exchange, for example, there was an idea. We need to settle on the naming scheme, to hash or not to hash. That's the question. And if that's something that the working group would like to get involved with and finds it interesting, then we would be glad if the group considered adopting this draft. Thank you.
Thank you, Peter. We're right on the end of the session. Excuses. Oh, sorry. Still, I want to give the opportunity to give feedback. People from the room. Victor, please go ahead.
Fantastic work. Let's adopt it without the hashing.
Okay, thank you. So there was also on the mailing list. Oh, sorry, Paul, please go ahead. As I saw your name. Paul,
I did the wrong button. I'm sorry. I also just want to say, because I've given a lot of comments about the small bits of the proposal I did not like, let me just emphasize as well that the majority of the proposal is awesome, and I think we should adopt it and continue with it.
Okay, yeah. I did see feedback on the mailing list. So there's interest in the working group. I also hear support in the working group here live. So Peter, as you might remember yesterday, I'm not sure you were able to attend to the opening of the Nsop session.
I think I was.
Yeah, okay. So we are accepting new work. I will switch on my microphone. So we are adopting new work, but in a controlled way. So the chairs will reach out to you. And given the work we are now completing and sending to the ISG for review, also new work is adopted. You are on the short list, but again, we will discuss it with the chairs and with you, and make an estimation of amount of work and manage the work group load.
Sure.
Suzanne, Tim, sorry, Peter, you want to add something?
Not really. I just wanted to thank everyone who chimed in on the hashing discussion, because that's obviously the most valuable type of feedback.
Okay. Thank you for your presentation and your contribution. Suzanne, please.
Sure. Just wanted to say thanks to everybody and just remind people that we had tried a couple of things with reporting more to the working group and running interim meetings between IETF week meetings, and those seem to be successful and helpful to everybody. So we're going to continue to do those things and watch for questions about proposed dates and proposed agendas for the next interim.
Yeah, indeed. Thank you. I would like to thank you, the working group, for your the positive discussions. Really good. I really enjoyed the sessions from today and yesterday. Please continue discussing these issues on the mailing list. And also excuses, we're running out of 4 minutes beyond the time slot we were allocated, so it might clash with your agenda. Excuses, but again, I think we had a very good session. thank you all. See you at one of the interims we are planning in the next month, and for the next IETF 113. Bye.
Bye all.
Thank you. Bye.